I'll better get the diagram clearly. So here they are they are available. And from here is our tent. From here, we are going to launch it. It should go and strike the enemy camp. Again, here the condition, look at the viscous drag is there. Air resistance. The air resistance is what I'm going to take help of it. And there's the height of the cliff. The cannon, here it will be launched. When it's striking, it will strike normally.
With terminal velocity.
Oh yeah, that's all. That's the condition. At what horizontal separation from the enemy camp should the soldier install the catapult to hit the enemy camp? So what is the thing? I think he is asking this distance. So what is the basic necessities? I'm going to take the air resistance into the picture. It will move with a terminal velocity. I think the trajectory I'll give it. So directly straight away jump to the problem. Air resistance reduces the speed of the stone at a rate. Look at that 0.1 meter per second per meter, not per, like you have to look at this unit. What is the unit for K? Speed per minute, means as it propagates, the air resistance will decrease the speed. Previous problem. That's why I asked you to previous problem, resolve the viscous drag along X, along Y. Along X axis, the viscous drag will see that for every 1 meter, the speed of the cannon will be decreased by 0.1 meter. That's the meaning of this. You look at this parameter. So again here also, so shall we, what actually happens here? If you look at the motion, mg, the viscous drag will act along the path and there's a velocity. So will you go for this analysis? Look at all the things. Will you go for this analysis? This will be the path of cannon. Shall we go for describe the motion of cannon like this? I think we'll land in a big trouble. Instead, he has given some information. The resistance spread is stone at a rate and there is no wind. Horizontal can you hear me? Shall I continue?
Yes, sir.
Yes, okay, we'll do one thing. Yeah, last 5 minutes we'll wind up this problem. Huh? There is a connectivity problem here. So therefore, what is that K? I'll write it. The K is what we should interpret. It is equal to this much K. Okay, dvx equal to K into dx. It's asking at what horizontal distance it should be. So this I'm going to integrate. What should be the initial velocity of projection? U cos theta. Finally, if it lands vertically, problem solved. Sir, how come you can see? Can you hear me? Shall I continue? Can you hear me? Anybody? Just
Yes. Yes, sir.
yes. Okay, we'll finish off. I think mobile data not possible. Will somehow will manage. Okay, this will become u cos theta equal to kx. So this x equal to u cos theta by k. This is our answer. If he has not given horizontal speed, not possible. If he has given horizontal speed, okay, we can solve. If not horizontal speed, very difficult, we can't work out. So that sentence is what the word is missing. I added up. Reduces horizontal speed.
Screen is not shared.
Resistance reduces horizontal speed of the stone at a rate yeah, this is what missing. I just somebody clarifying something. Hurry up. The connectivity, the problem is there.
200 meters out.
Okay, fine.
Voice is breaking, it could not hear.
Yeah, that problem. I'll end up the class. Huh? If you want, you can take screenshot this last one.